Good morning, children. In continuation with the chapter 2, electrostatic potential and capacitance, today I am going to start with the topic energy stored in a capacitor. Let's start.
The process of charging a capacitor consists of transferring charge from the plate at lower potential to the plate at higher potential. The work done in the charging process is stored as potential energy of the capacitor.
Now the process of charging the capacitor, this is our capacitor which is connected with the battery. The positive terminal is connected with the positive plate of the capacitor and negative terminal is connected with the negative plate of the capacitor. Here we have to charge the capacitor. The process of charging a capacitor consists of transferring the charge from a plate at the lower potential to the higher potential. The work done in charging the process is stored as the potential energy of a capacitor.
At charging process, the potential difference between the plate is V is equal to Q by C. The additional work dW needed to transfer the next increment dQ of charge is given by dW is equal to V dQ, which is equal to Q by C into dQ. The total work required to charge the capacitor from its initial value 0 to a final value Q is given by integration of dW. Put the values of dW in the equation. We get W is equal to 1 upon C integration from 0 to Q of Q dQ, which equals to Q square upon 2C. Thus, the energy stored in the capacitor is given by U is equal to 1 by 2 CV square.
So in the previous slide I have taken the small w dW. So to take the total work done, integration from 0 because starting my initial value is 0 till the charge Q. 1 upon C is constant which is come out from the integration. After integration Q, that is Q and applying the upper limit minus lower limit, you will get this value Q square upon 2C. Therefore, this work done is stored in the form of potential energy. The energy stored in the capacitance, this work done is equal to potential energy, and Q upon C again is V, and your value is replacing the Q, so you will get the half CV square. This is the amount of energy stored in a capacitor. So children, next topic is our
Van de Graaff generator.
See, Venn diagram generator, it is not in the syllabus of 12th class. So this topic I'm going to skip it, and please do not read this topic from the NCERT book also.
Working assessment. Before proceeding further, let us know how much you have learned. Click true or false.
When a positive charge conductor is connected internally with the hollow conductor, the whole of its charge flows to the outer conductor. It's true.
Good job.
In parallel combination, negative plate of one capacitor is connected to the positive plate of the other, and so on. Let's see, it's false.
Good job.
Now this is we haven't done it. In Venn diagram generator, the charge particle can be accelerated to the high energies.
Try again.
As we haven't done it.
Good job.
So this topic is, we are not going to start with this topic. Now this is the last topic of our chapter. This chapter second, electrostatic potential and capacitance, is over. From tomorrow I'm going to start with the next chapter. Before ending up this chapter, let us summarize what we have done it.
Because of the ability of the capacitor to block current flow, it is often used as a filter. An interesting demonstration with the Van de Graaff is to make someone's hair stand on the end. Dielectric mirror is composed of multiple thin layers of dielectric material, typically deposited on the substrate of glass or some other optical material. Summary. Let us summarize what we have learned. Polar materials are composed of molecules that have permanent electric dipole moments. Non-polar materials contain molecules that do not have permanent dipole moments. The extent to which the molecules of a dielectric become polarized by an electric field is described by a vector quantity called the electric polarization. Capacitor is a device that consists of two conductors isolated from each other so that they can be given equal but opposite charges. Capacitance is defined as the ratio of the magnitude of charge on either conductor to the magnitude of the potential difference between them. The dielectric constant of a dielectric is the factor by which the capacitance of a capacitor increases from its vacuum value when the dielectric fills the entire space between the plates of the capacitor. When a positively charged conductor is connected internally with a hollow conductor, the whole of its charge flows to the outer conductor.
Now this chapter is over. We already have summarized whatever we have learned from this chapter. And please do the worksheet which is I'm uploading in ERP and notes also. Please do all the things in a fair notebook. You will be assessed 5 marks in your half-yearly exams or in exam which is held in May also. Thank you.